Okay, my friends. So here is one more Monte Carlo simulator that's going to be able to roll a bunch of dice. If I was in class with you, I would have done this with you. It would have given you all a pair of dice. We would have rolled them. I'm sure we'll do that at some point. But here we're going to have Excel do it for us. So we're going to have die number 1, which is generated. I don't know if you can see the command up here. It's a rand between command that generates a random number between 1 and 6. This is die number 2, does the exact same thing. And then this puppy dog down here just adds them together. So I just hit enter and it rolled a 3 because we have a 1 and a 2. And you'll notice that the cumulative counter over here added 1 to that. If I roll again, I got a sum of 8 down here. If I roll again, I got another sum of 8 in a different way. That was kind of cool. There's a sum of 6 with a 2 and a 4. There's a 6 and a 3, a 3 and a 2. Now notice it's just populating column F. And I was kind of hoping there's another way to get an 8, a 6 and a 2. So what you're seeing is, you notice how you get the same sum over and over again, but in different ways. That's because each of the ways up here is an outcome, but the sum is the event, just using that word again. Now, what I can do is I can keep on doing this and keep on, throwing dice and keeping track of the sums. I'll do it, you know what? I'll do it 36 times because 36 is that number that we came up with how many different outcomes there were. Now, if I take a look over here, I'm going to slide this graph over a little tiny bit. There. That, my dear friends, is the results, or are the results, I guess, that we just got. And the graph right next to it right here, these are the theoretical probabilities. These are the percentage forms. On the in the notes, we call them 1 out of 36, and 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, and then back down. That's what that graph would look like. This graph really doesn't look like it too much right now, but let's keep rolling the dice and let the sums kind of populate. Like, for example, it took me till right then to finally get a sum of boxcars, and then I just got a second one. That's actually really, really funny. And there's a third one and a fourth one. I'm going to stop talking about them now, because now we are starting to see the graph still isn't perfect. And I love looking at these graphs in this way. I remember using this years ago in a stats class and comparing, again, what we are supposed to get over here in the theoretical to what we are getting experimentally. And one of my students said, "Man, it's like watching evolution," which was such, I just thought, a super, super duper clever way of, yeah, it is like watching evolution. It really, really is. Because if you take a look at the graph to the left and to the right now, and then look at the percentages, side to side, they're exceptionally close to each other, right? Now, I noticed, it just happened to look down, the probability of 2 is a little high right now. It's at 3.4%, and it should be at 2.9%. So it's about a 0.5% high, but even as I was saying that, it's starting to drop because you're watching the probabilities evolve over time. So if I just keep my finger down on this F9 button, which is the one that's actually rolling the dice over and over again, you'll see this as we do this more and more in class. You're beginning to notice that the graph on the left, while it's still shimmying and shaking, is shimmying and shaking a lot less because its probabilities are beginning to fall in line with what the theoretical probabilities say they should be. And that's exactly what the law of large numbers tells us what happened. It says if you repeat an experiment enough times, and right now we're about 2,200 trials and counting, the experimental probabilities will begin to approach the theoretical probabilities. So the theoretical probabilities, the perfect probabilities, the ones that are the exact, will become approached by the experimental. Which, and you're going to read this in the notes in a second, I once had a student that asked me, well, if that's true, why don't we just always use the theoretical probabilities? And that's going to be the last set of questions on the notes. So check those out next.